So today we're going to be going over circle equations, which are worth 25 points on the SAT, so definitely a concept you need to know. Our approach on these is going to be to identify circle equations questions. We're going to break down the question. We're going to build a formula to solve them. Then we're going to solve a practice question together. So how do you identify these? Well, these questions will test your understanding of the formula of a circle. Now here is the standard form of a circle, and these h's and k's and r will be replaced by values. But for example, we could have x minus 3 squared plus y plus 4 squared equals 5 squared. Now for the standard form, your center of the circle is going to be h comma k, so we reverse the negative signs. In our example up here, if we do that, our center would be 3, negative 4, and then our radius would equal 5. Now something I want to mention right here, and it's because they get kids every single year with this one little trick, is that what they'll often do is they'll put the radius as like 25, and they'll put the rest of the equation like how we wrote it up here, so x minus 3 squared plus y plus 4 squared. And students really forget, especially if they're going quickly, that this 25 represents r squared, not r. And so they might give you this equation and ask what r is, and they'll have an answer like r equals 25 or r equals 5. You have to remember that what's on the right side of the circle equation in standard form is r squared. And so if you have a 25 here, set 25 equal to r squared to get radius of 5 and pick the right answer. Now the things they often ask you about are center, radius, or they'll want you to convert to standard form, which we'll see here in 1 second. So here's the formula we're going to be using for these. First, we're going to identify our circle equation. Next, we're going to convert to standard form, and that's if we need to. And then lastly, we're going to determine our answer and check with Desmos. Now Desmos is going to be a must-use here. You'll see in a second the math can get a little hairy, but Desmos is going to make it much easier. So our example reads, in the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 10y equals 33. What is the radius of the circle? So it's really tempting to see here the 33 and just want to square root it and pick d, but this is not correct because we're not in standard form, so we can't do this yet. And so that means d is wrong. So I'm going to start by factoring out 2 from the left side of the equation, which will leave us with this. I'm then going to divide by 2. Now this next move might seem a little bit confusing to you, but just see how we do it here and try applying it on your own, and it'll make a little more sense. But basically, we're going to complete the square, and so we can find our center. And what this is going to look like is you're going to take the term in front of the x, you're going to divide it by 2, and then you're going to square it. So for this one, x squared minus 3x, and we're going to divide by 2 and we're going to square it, so that would be 3/2 squared, and 3/2 squared is going to be 9/4, and so whatever that gives us, we're going to add and subtract. So here plus 9/4, and then outside of the parentheses I'm going to subtract 9/4. Now as you can see, we added and subtracted 9/4, and so we're actually not changing the equation, but we're rewriting it in this form for a reason you're going to see in 1 second. Now we're going to do this for the same, and this is actually going to be inside these parentheses still 2, and we're going to do the same thing for the y's. So y squared plus 5y divided by 2 and square is going to give us 25/4, so plus 25/4 minus 25/4. Okay, so now that we've done that, this still equals 33, and this should be 33/2. 33/2, and now since we do these completing the squares, what we can simplify this first term to is x minus 3/2 squared. And then we still have this minus 9/4, and for this one, we can change it to y plus 5/2 squared, and we still have this minus 25/4 equals 33 halves. Now what I'm going to do is I'm going to add the 9/4 and the 25/4 to the right side so we can clean up the left side of our equation to look like the form that we can extract important information from, the standard form. And I'm going to convert 33 halves to 66 fourths, so we all have fourths. And now lastly, in this last step, I'm going to get x minus 3 halves squared plus y plus 5 halves squared equals 100 fourths. And 100 fourths equals 25. And so r squared is 25. And we divide, or we square root both sides. We get r is 5. That's going to give us a. Now I know this is a lot of math. I know these can look scary, but don't worry because first, this is a hard example, so I picked a harder question for us to go through. So when you face these on the real test, they're not as tricky. And then the second reason why you shouldn't worry is because we can actually do all of this in Desmos and not have to worry about all this hairy work. So let's go over to Desmos. So now that we're in Desmos, I plugged in the original equation they gave us, no manipulations, nothing. And what I can do is I can find a point on the top and bottom or left and right. So I'm going to pick this bottom point and the top point, and I'm going to see what the difference is between these y values. So our top one is 2.5 and our bottom one is negative 7.5. So the difference between those is going to be 10 units. So if we have a line that goes from the top to the bottom of our circle in the center, that's going to be a diameter. And if we know that diameter equals 2 radius, then our radius is just going to be half of our diameter, which here is 10, and half of 10 is 5. And so this was a much easier way for us to see that our radius is 5 without having to do all that hairy math. So definitely plug into Desmos for these, whether it's to just get the answer, or if you did all the math and want to check it, plug in Desmos. A is correct. And we went over some Desmos shortcuts, so good luck on these.